Shab is the creator of Weather Central. If you go to my website, weathercentral.wordpress.com, and you click on the Weather 101 page, you will be brought here to the list of all the different weather phenomena that we have. So the first one we're going to deal with, as promised, is the thunderstorms. And a thunderstorm is a type of rainstorm where thunder is typically heard. And typically these only occur in the spring in the Midwest of the United States and in the eastern third of the United States in the summer. The reason why the Midwest is such a hotbed for these types of storms is because you have the convergence of warm, dry air from the desert Southwest, from Arizona, from Utah, from New Mexico, and the more warm, moist air from the Gulf of Mexico. That coming together in the Midwest, or known as Tornado Alley, is one of the ingredients for thunderstorms. So just here are the three different stages of a thunderstorm, and before we get to the stages, a thunderstorm needs three ingredients. The first one we dealt with already is moisture. So we have the moisture from the Gulf. Another one is unstable air and rising air, and that is caused by the sun heating the ground. And since heat rises, we have the warm air that was heated, the air from the ground that's been heated by the sun rising. And one other thing we need is to get that warm air rising, and we need some sort of lifting mechanism. So an example of that could be a cold front, which is the borderline of a different air mass to another one. That will get the lifting motion going. We also can have orographic lifting, which is caused by either mountains or any other elevated landscape. For example, we have the Rocky Mountains, and if you have a storm coming from the west, from the Pacific Ocean, the storm will be lifted into the Rocky Mountains, and the rain will essentially get caught in the mountains, and it'll rain in the mountains much longer than it would on flat land. So that's an example of a lifting mechanism. So here are the three stages. We have towering cumulus stage, mature stage, and dissipating stage. So the first stage is we have the developing stage, and this is when warm air rises from the sun-heated ground, as we talked about earlier, and we have an updraft that's created, and you can see from the picture here we have the lines pushing up the air to the cloud and making the cloud rise. And once the cloud rises, it gets colder, it cools, and it condenses into water vapor. And then once this water vapor gets high enough, it reaches a level where the cloud is below freezing, so these water droplets begin to freeze into ice crystals and ice particles. And when these ice particles remain in the top of the cloud from the updraft, they'll start accumulating more layers of ice on it, and then we can have some hail form. In severe storm, once it gets strong enough, we can have hail falling from the storm. Usually in this stage, we don't really have much rain, but we could have lightning and thunder because of all the charged particles that are created from all these ice pellets rubbing together and accumulating an electric charge. So this will continue into the mature stage, and at this mature stage, the cloud can skyrocket to over 40,000 feet. You can see it from airplanes. It's really cool to look at. And the updraft usually reaches its strongest intensity at this point, and we could have some really serious hail forming there. Addition to the hail, we have the rain will start to fall. We have heavy rain, gusty winds, possibly tornadoes, and a lot of thunder and lightning. And also, when the rain starts to fall, there's a downdraft that's created, and this is simply just air moving down, just like an updraft moves up, downdraft moves down. And when the downdraft moves down because of this rain-cooled air, it creates what's called a gust front, and this is pretty much a line of gusty winds that precedes a thunderstorm. So if you're standing outside and you see the sky is getting dark and you get hit by like a gust of wind, that's probably the gust front, and you should probably go inside to safety. Sometimes if these storms get strong enough, they reach what's called the tropopause, which is the end of the troposphere, which is the troposphere is the layer of atmosphere that we live in, where all the weather is formed. And the troposphere is typically cooler than the stratosphere, which is the layer that is above the troposphere. And since the stratosphere is warmer than the troposphere, usually the cloud can't rise above it because the air is equal outside, so it can't rise anymore. And we have an anvil type of shape that's formed. I'll show you a picture a bit later in the screencast on that. So you have this intense storm going on, and at a certain point, the storm essentially rains itself out. This is the dissipating stage, and this is when the downdraft is stronger than the updraft. So we have a lot of air that's getting pushed down and a lot of rain that's coming down. So the storm starts to weaken because there's nothing in that's fueling the storm anymore, since this gust front that was created pushes ahead of the rain, which will cut off the source of moisture. And when the storm has no moisture, it can't rise anymore. So rainfall intensity usually decreases in this stage. You still could have thunder and lightning, but usually it's not as intense as it was during the mature stage. And also, we do have, typically when these storms start to weaken and once these storms pass, the air is much cooler than it was before because the rain cools off the air. So here are some of the major types of thunderstorms that we have. These are probably the big three. First example is a squall line or derecho. This is, as you see on the left picture, is a line of thunderstorm, very strong thunderstorms. The reds indicate very strong precipitation, very strong storms. And it's in this bow type of shape, similar to the bow echo that we'll talk about in a bit. And these squall lines and derechos are usually accompanied by very gusty winds, so they're very dangerous. And even if there are no tornadoes, they can still be very dangerous because of all this straight-lined wind damage, which is the term that we use to explain the kind of damage. The second example is a supercell. You may be familiar with this if you're from the Midwest. This is kind of the classic shape of a thunderstorm. You see these the fluffy cumulus clouds in the middle, and that rises up to like an anvil shape. If you take a step back, you can see it looks like a bit of an anvil, and that's where we have the equal level of temperature in the cloud and above the cloud, and this picture is the stronger at its mature stage. The third example is a bow echo, similar to the squall line and derecho. It's just not as large as the squall line and derecho. Derecho and squall line can span a bunch of states. The bow echo can span maybe a couple of counties. But bow echoes are usually much stronger, and also they can sometimes contain tornadoes. And as you see, it has this bow type of shape, hence the name bow echo. And these also are accompanied by strong winds, strong and gusty winds. So I hope you all now learned a lot about thunderstorms. If you have any questions, you can always go to my website and leave me some questions, and I'll get back to you as soon as I can. I hope you enjoyed. See you guys.